So thank you very much for having me here today. I'm very happy to be presenting my work. I'm an independent researcher with Gilles and Leila, my partners. We set up a new company a few years ago, and we are doing now monitoring with private clients, with mostly public entities. So for this project, we worked for our client in Aix-en-Provence, which is south of France. Climate there is quite nice, Mediterranean climate, where it's dry and warm in the summer and never very cold in the winter. And it rains relatively okay, never too much. So inside, we are working in a unclimatized, unheated church, and we are trying to study the wooden sculpture inside this church before and after freezing treatment for removing woodworms. So here a little presentation of our work, how it became. Look here in Aix-en-Provence, the Madeleine Church. So it's a wooden sculpture from maybe alder that were placed above the organ. We are studying an angel, like a human-sized angel, as you can see here, and a fire pot, because it represents fire in the pot. And you can see a lot of damages due to woodworms. And actually, this is quite severe because it's extremely fragile. Some damages have been happening in some of the sculpture. And there is plenty of major cracks around following the rays, as usual, in the sculpture. The idea was to monitor before, after freezing, on the major cracks, but also to be able to understand if the cracks were opening due to damage. We decided to measure the cracks linearly with a sensor, a linear sensor. And on top of that, we also set up some strain gauges to measure the normal swelling in tangential and radial direction of the wood. The idea was to avoid those, it was a bit difficult to avoid the woodworms, but we found some areas, that was fine. So here's the application of my colleague, Gilles, who is a conservator. And so it was very like science and conservation together. So the idea was to separate the work into 3 different phases. One at what I called quasi-equilibrium phase during 3 months in a stable condition. Stable, we define maybe what is stable later. And also 3 months in a dynamic condition, so in the church, which is unheated and not controlled at all. And that each time before and after treatment. So treatment meaning freezing treatment. Here the lab where we are settled. The lab is inside a private conservation center, specialized in wooden objects. So the idea was to indeed have those wooden objects controlled, and that's for the light for catching the woodworms when they fly off, because they do. And we try to control indeed the climate in the lab. It is empty lab, now it's full. Yes. So the idea was we applied what in France we do a lot. It's been roughly settled that we need to freeze for minus 25 degrees Celsius, which is minus 13 Fahrenheit, if I remember correctly, for 1 centimeter, 1 hour per centimeter. So because it's large wooden objects, it was 24 hours at minus 25. And then the idea is to avoid condensation, to very slowly go up in temperature. So it took like more than 7 days. And we monitor all the process during also. When that is done, we brought basically the statue back in their normal environment and finish the project as it was and dismantle the sensors. under the tape is strain gauges. We had to prepare them properly to not damage them because they're extremely fragile. So all the data you are going to see, they are corrected with temperature, the temperature data from the calibration. So as I said, so we have the freezing treatment, 24 hours at 50% relative humidity, minus 25 degrees Celsius, and it took around 3 days. Actually, it took longer, but usually it's around 3 days. And then quasi-equilibrium behavior before-after treatment and dynamic behavior before treatment. When I say dynamic behavior, obviously this is not a real dynamic. It's more like we are like just monitoring in their natural habitats, relative humidity changing in the church. So here's the overall results for the Angel. The idea is to show you basically what's going on. We have the freezing treatment here, where we can see very well that he went to minus 25. Then we have before the stable, before freezing the stable condition, where we could also compare after freezing stable condition, and same for in the church, what I call the dynamic behavior, and after in the church. There is a gray area which I'm not going to treat because I'm not sure about the reliability of my data for this part because it's a lot. We go actually for the Angel to like minus 5% of opening of the crack, which is very surprising in a very short amount of time. Same for the Firepot. We have the freezing treatment. Then before freezing, stable condition. After freezing, stable condition. And then the dynamic condition before freezing and after freezing. And the gray area, again, I'm not going to talk about it right now. I don't have enough data and it's too much questions for me. So just quickly about the freezing treatment. Someone once told me, you won't see anything. Freezing treatment on wood is fine. Like, okay, let's try anyway. Let's try if there is indeed no effect on wood before after freezing treatment. So as you see, as reality shows often, things doesn't go very well. We try to reduce the temperature, but we had a problem on the climate chamber. And then we had to do it again, basically. So that's why it's like there is in temperature here, we have like a raise again. We basically open the door and then we had to do it, the treatment again. So the real treatment is this part here and then slowly going up in temperature. We only moved the status when actually we reach mechanical equilibrium, which is here. Yeah, that's what I said. Yep. So for the quasi-equilibrium behavior, I call it quasi-equilibrium because the lab was not perfect. It's not a working climate chamber. It's just a lab, but it's better than the church. So basically, we have quite a stable temperature of around 17 degrees, 17 and 20 degrees, and fluctuating between 48 and 55 most of the time. We have monitored the opening of the crack, of 2 large cracks, and then on the same, next to it, on the bulk strain, so it's micrometers per meters, so 10 power minus 6 strain. So we can see there is a lot of change, even though the climate should be quite stable. And that could be, that shows a lot of data that I'm only able to analyze if I do statistical analysis. So basically here, I run basically histograms on strain versus relative humidity, and I try to compare the most occurring event. So here I'm comparing basically my relative humidity happening around 47 to 50% of relative humidity towards actually my here the most occurring event, which is around -1%. And I'm going to compare before after freezing those data. You can see that sometimes I don't have a normal law or distribution, so that's why I actually do histograms like that of repartition of my data to not apply just a mean or an average on data that don't have actually an average that means anything. So we do the same so for the Angel and for the Firepot here, and here is very clear that we don't have a normal distribution, for example, on the Firepot, on the crack happening. So here are the results. Basically, if I go back, we can see that before freezing, unfortunately, we had different events happening. So before freezing, we were more in spring. So relative humidity of equilibrium was more around 50%, where after freezing, we were more like summer / beginning of fall. And then we were basically more dumper. So the idea is to compare what is comparable. I can compare data from 50 to 55. So I'm trying to basically move all my data around 55% of relative humidity for this case. So that's why here for before freezing, the Angel and the Firepot are around 55% of relative humidity, and the strain in tangential direction, the strain in radial direction, and the strain crack, basically the relative movement of the crack according to the initial length. So we can see that as, let's say, stable condition, we actually have mostly after freezing strain that reduces after the freezing treatment, except for one case of the crack of the Firepot. This crack was extremely large and maybe gave always weird results, I would say. But generally speaking, stable to stable before and after freezing, we do see a tendency of decreasing magnitude of strain. Now the more dynamic behavior is a bit more complex and the results are less clear, but let's try anyway to analyze what happened. The idea was to apply the same methodology. Basically, you can see here, before we didn't have a normal law here and either, so we have it's very difficult to find actually a repeated behavior, which I'm not surprised, because the climate is not stable at all. But the idea is to still have to take the highest occurrence here, the dark points, and to compare them before after freezing for both the Angel and the Firepots here. So we can see they have for the Firepot, I like it. It makes like little balloons shape. Because it's a bit more complicated, obviously I couldn't find reliable data to compare between each other, for example, so I had to basically choose a relative humidity, one comparable for the strain, like the normal strain of the swelling and shrinkage of the wood itself, and different than actually the crack opening. So I compare 65.8 here % of the before freezing of the strain crack, and crack strain, and then I compare it to this data. So unfortunately, we can see that we have actually contradictory results in terms of here we are more in compression at the same humidity, almost the same humidity levels. We are in compression in both tangential and radial direction, before and after freezing. But let's say in magnitude, we do have less swelling and shrinkage happening. So here in the fire pot, for example, before the freezing, we had almost we had more than 1,000 micrometer per meter, where after freezing we are 10 times less on magnitude again. It's just for the crack strain. The crack strain, we do see more opening here. So I suspect data needs to be more analyzed in depth, maybe with some modeling. I suspect there is maybe some damaging happening in that case, but I can't answer this question by only looking at those data if I don't have a model that runs on the same time, which I don't have. So it's interesting to see that actually in a long-term behavior, there is things happening when we freeze wood. And this is wood that doesn't have any coatings. It never been painted before, so it's like a pure, probably alder wood. So here my conclusion is basically for the stable condition before after freezing, we can see there is definitely a decrease in miniature, in swelling and shrinkage behavior in both tangential and in radial direction. In dynamic behavior, I'm a bit more careful. We're saying that it seems that we have the same behavior of decreasing magnitude in swelling and shrinkage ratios. And the crack is shown as very unstable after freezing. I do not say freezing is problematic for wooden objects. I just say we need more research about it, because in France, the general outcome when we ask to the specialist what's going on, it's fine, nothing is going to happen to your materials. And with this research and with my clients, we, thanks to my client in the Aix-en-Provence city, we showed that basically research needs to be a bit more made to have a better understanding of what's going on when we actually are freezing materials for infestation of woodworms. I would like to thank everybody that was involved in this research and my clients from the City Hall of Aix-en-Provence. Thank you very much.
Thank you, that was great. All right, let's throw it out to the audience. Any questions? Here we go.
Thank you, Cecilia. It's just a short question. How does the freezing or this lowering temperature affect the moisture diffusion in the wood? Do you expect that it would change? It would explain why you get this different opening?
So,
maybe?
yeah. Actually, usually we say that freezing in any change of temperature would affect indeed the moisture content in the wood. The idea is for these purposes, we did have climate control in the freezer. So it's a very specific freezer where basically relative humidity is always constant. So we do not expect moisture content to be such a change during the treatment. So if there is change happening, it's really due to the temperature change.
Any other questions? Okay, I'll ask a question. What were the kind of standards that you were following in relation to the freezing treatments? And is it a standardized method or a modified standard?
In France, it is not an official standard. It is part of one researcher doing research for many years, but it's only one person and it's not been commissioned in front of many experts. So I would say, we need more standards. I know we are not big fan of standards usually about climate, notably, but conservators, because that's my work now, is to really work with conservators and give them guidance. They really need to know when the client calls them and they say, we need to get rid of the woodworms. and what do they do? So we need to give them, and they need precise procedure, like, okay, a centimeter, an hour per centimeter of at minus 25. Is that based on which kind of reality and research? That is not really, that is fine, but it's more like what happened to the wooden structure and so on. Is it safe? That nobody has any clue. That's why freezing treatment is not popular, because everybody is very scared of it and there is not enough research.
And did you consider heating treatments? Because I know that raised temperature with controlled, obviously, moisture content is an option. So
yeah.
Have you looked into that as well?
We looked into that. We even had an ICOM CC session in Valencia last year. The thing is, there is not also many research around solarization or heating treatment. My personal experience with heating treatment, it damages the wood. If you go above 90% 90 degrees Celsius and 0% of relative humidity, if you go even further than this humidity or further than this temperature, you will have mechanical change in your properties of wood.
Yeah. Great. Okay. Please.
Hi. I wanted to ask about the mounts that you used for the sensors, because I saw they were mounted on, well, there was a glue and there was plywood.
It's in the, I can show you. It's in the video. Yeah?
Yeah. So how did you come to those materials and their influence on the measurements? Like, do they react and contract and undergo the freezing?
That's a difficult question to answer. In front of museum people, because we use synthetic glue that doesn't react to humidity and less to temperature change. We use epoxy glue because in France we have a difference between museums and historical monuments, heritage, build heritage, and in build heritage we can do this kind of things. It's allowed. So we use epoxy glue to glue our sensors.
Do you want to come back on that? Anybody else? All right. Thank you so much. That was great. Another round of applause, please. Fantastic.